Hey guys. Okay, so this is another video on using truth tables to test for validity. So in the last video, we used truth tables to test the validity of modus ponens, modus tollens, affirming the consequent, and denying the antecedent. When we did that, we first assumed that all of the premises were true, and then we used the truth tables to determine whether or not it was possible for the premises to be true and the conclusion to be false. If it was possible for the premises to be true and the conclusion to be false, then we knew that that argument was invalid. Remember, arguments are only valid when it's impossible for the premises to be true and the conclusion to be false. So when we were going through those four, we took every premise individually, we went back to the truth table, and we said, okay, which rows is this premise true in? And then which row is the next premise true in? And in that row or rows, is it possible for the conclusion to be false? And it was kind of tedious, and it took kind of a long time, as you might have noticed. So that's a really good way to get started. And when you're still feeling shaky about your truth tables, you should definitely be going back and checking the row every time you bring something new into your evaluation. But as we go through this, we get more practice and we get more comfortable with truth tables. We don't have to go back to the row every single time. We can just use our knowledge about truth tables and about checking arguments for validity to guide us and to speed things along. So we're going to try to do that in this video. We have two arguments that we're going to start with to try to test for validity without having to spend so much time referring back to the truth tables. Okay, so since we still are using truth tables, I have them up on the board. We have conjunction, disjunction, a conditional. We have the negation here. I have negation for P and Q. They're the same. In fact, the reason I put both of them up was just to remind you that they're the same. This is going to be the truth table for the negation of any variable. It's actually the same for all truth tables. You can put different variables in here and the truth table will stay the same. So we could have A and B, and then if A, then B here, the truth table would still look the same. So that was just a reminder. Possibly different variables are going to show up on your homework, so be ready for that. The last truth table is one for a triple conjunction. So this is P and Q and R. I haven't filled this in yet. We're going to fill it in together. So first, we have 8 rows here because remember, the number of rows in a truth table is the number of truth values that you have. That's always 2, true or false, raised to the power of the number of variables that you have, which in this situation is 3. So your number of truth tables here is equal to 2 raised to the power of 3. That's 8. These 8 rows give us every possible combination of P, Q, and R being true and false. All right, so this is a conjunction phrase. Under which rows, row or rows, do you think that this whole conjunction phrase is true? It's only true in one row, the first row. And remember, under what conditions is a conjunction claim true? A conjunction claim is only true if all of its conjuncts are true. So if P and Q and R is only true if P and Q and R are true, and that's in our first row. So P, Q, and R is only true if P and Q and R is true. So I'm going to write true in the first row and false in all the other rows. All right, one more time. This is P and Q and R, and it's only true when all of the conjuncts are true. We're not going to use that in this video, but you are going to use that on your homework. So I wanted you to have that truth table with 3 variables here. So I'm going to move aside. If you haven't written this down, go ahead and pause the video and write it down now. Okay, so let's start with our first argument. Our first argument is going to be P, Q, therefore P and Q. Okay, is this valid or invalid? This is valid, and this is a pretty simple one, so it's a nice place to start. So our first premise is P, our second premise is Q, and our conclusion is P and Q. Remember, an argument is valid if it's impossible for the premises to be true and the conclusion to be false. And when we're testing for validity, we go ahead and we're assuming that all of the premises are true. So if it's true that P, and if it's true that Q, then we know that it's true that P and Q. If P is true and Q is true, then P and Q is true. We don't need a truth table for that. We do have it on our truth table. We know that if P is Q and Q is true, then P and Q is true. But we didn't really need to go back to the truth table for that. We're familiar enough with conjunction to see that this is valid. Okay, great. So that's our first argument. Unfortunately, most of the arguments that you're going to see in class are not going to be as simple as that, but it's a good place to start to see that it's not always going to be the case that we need to use the truth tables in order to figure out if our argument is valid. So our second example is this. Say if A, then B, it's C or B, not C, therefore, sorry, this is C or A. Sorry about that, you guys. So our second premise is C or A, and our conclusion is B. So first premise, if A then B, then C or A, then not C, therefore B. Okay, can we use any of these premises to tell us more about another premise? We can use the third premise to tell us more about another premise. Which premise does the third premise tell us a little bit more about, one or two? The third premise tells us more, obviously, about 2. That's the only other premise with C in it. So with the third premise, we know that not C is true. Again, testing for validity, we assume all of our premises are true. So we're assuming it's true that not C. If not C is true, that means that C is false. So say not C is true, that means that C is false. We know that now. All right, and in a disjunct, we know that this whole disjunction has to be true because it's one of our premises. We're assuming it to be true. So if it's true that either C or A and C is false, then that means that A has to be true. So now we know that A has to be true. Okay, with this knowledge, can we learn anything about one of the other premises? Yes, if A is true, then that means that we can learn more about premise 1. So A is true, and our whole first premise is true. So I'll put a little T here to remind us that this A is true. And we know that this whole premise is true, so we know that it's true that if A, then B. And we know from our conditional truth table that if the conditional is true and if the antecedent is true, then the consequent has to be true. So if premise 1 is true and if A is true, then B has to be true. That means that if all these premises are true, it has to be the case that B is true. So B must be true. It's impossible for these premises to be true and for the conclusion to be false. That means that this is a valid argument. Awesome. Okay, so we've seen 2 valid arguments, and we didn't really have to spend that much time going back to our truth tables, which is great. So what if we changed this just a little bit? What if we said that our conclusion here wasn't B, but instead, what if we said our conclusion was not A? Then what? Okay, well, we still get some information from our third premise that we have to apply to our second premise. So we're saying all of these premises are true. If the third premise is true, then we know that C is false. Again, we're saying C is false. And if this premise is true, meaning C is false, then we know that A has to be true. So if C is false, and it's true that either C or A, then that means that A has to be true. Well, we've run into a bit of a problem already. What's the problem we ran into? So now we're saying that our premises make it the case that A has to be true, but our conclusion is not A. In our conclusion, A is false. So that means that it's possible for all of these premises to be true, but our conclusion to be false. If it's possible for the premises to be true and the conclusion to be false, then our argument is not valid. Okay, so now we've seen that, again, we can come to an argument. We can evaluate it for being valid without having to refer back to the truth table every step of the way. And we can evaluate an argument that is invalid without having to refer back to the truth table every step along the way. So that's what you'll be doing on the first part of your homework assignment, the one that's actually worth points. Some of the problems will be a little bit trickier, so please keep me posted if you have any problems. Good luck, and I'm looking forward to hearing from you all about the videos soon.